In this proof, we show that for any real number greater than 0, there exists a member of the natural numbers such that that number and the number right next to it in the naturals bracket y. We're going to start by defining the set S, which is the set of all natural numbers that are strictly greater than y. Then we refer to axiom 311, which is the well-ordering property of the natural numbers, and that states that any subset of the natural numbers has a least member. In this case, we're going to denote that number n. Since n is the least member of S, n minus 1 cannot be an element of S. Therefore, we know that n minus 1 has to be less than or equal to y, and the result follows. The second part of the exercise is to prove uniqueness. The standard way to prove uniqueness is to assume that there is another solution to the proof that's different than the original solution. In this case, we're going to assume that there's an m element of the naturals such that it satisfies the conditions of the proof, but is different than n. Now, since m is in set S, m is not the least member because we've assumed that m is different than n. Hence, m has to be at least as big as n plus 1, which is the same as saying that m minus 1 is at least as big as n. Thus, since n is strictly greater than y, n plus 1 is strictly greater than y, which contradicts the assumption. Therefore, it can only be the case that m is the same as m, and n is unique.